right, guys. On number 5, what symbol should go in here?
Greater sign.
Good. Great. Obviously, 32 is positive. It's going to be bigger than any negative number. When it gets trippy is when you have something like this in one of those. So we'll get to that here in a second. What's absolute value of negative 20? 20. Like absolute value will always come out positive. Or 0 at least, right? Because absolute value is 0. Why does, hey guys, why does absolute value always come out positive? What's it based on? I like it. Measurement from 0. It's based on distance. And you can't be negative feet away from something. That's a little freaky. All right, so absolute value negative 20 is 20. So what about this guy?
It'll be 5.
So what's that?
5.
With see, isn't that what I was talking about earlier? This kind of thing pops up a lot. That negative is just sitting on the outside waiting. He's not being affected by this, is he? And you got to be careful. You can't bring this inside and kill this negative because this absolute value is saying to do something. You have to do it. So absolute value is like parentheses. It's the same order in the order of operations. You have to do it first. I like it. So that's 5. And then you throw a negative 1. So that's a lot like the negative 5 squared that we were doing earlier, right? Because we always say when you square something, it comes out positive, and it does. That is 25. There just happens to be a minus sign in front of it. Same thing here. That is positive. It just has a negative sign in front of it. How are we doing about that? Because I always get a student that comes up, you just told me S value always comes to the positive. What the hell is that? Well, that negative is out there. I can't do anything about it. It's there. What about this one here?
Negative 2.
Yeah, is that 3 negative?
No.
But that 5 is, right? So they're opposite sides.
Yeah.
So you have to subtract. So 5 minus 3 is 2, but the bigger guy is negative. Negative 2. What helps out sometimes is 3 plus negative 3 would be what? 3 plus negative 5 goes even more negative. So that's why it comes out negative 2 at the end. So what about 7? That should be easy enough now. 0. Fill in the hole, right? 5-foot hole, 5 feet worth of sand. Fills it in. It comes back to flat land, 0. Guys, do I have to separate you? I will. I feel like I'm driving, old man driving. Don't make me stop this car. Number 16, what happens there? There's a few different ways to look at number 16. You can just attack it directly. You could rewrite it if you want to. Because plus and negative should kind of irk us a little bit. It's like 2 signs in a row. It's a little bit freaky. There's a lot of ways to do this. You could, what's the only operation in the whole thing? Addition. There are some negative numbers, but the only operation is addition. You can add whatever order you want to. 5 plus 7 is the same as 7 plus 5. So I saw somebody do the 20 plus 6 is 26. And what's the negative 11 plus negative 3? Negative 14, right? 2 negatives, so they're going to stay negative. When you add them, you get even more negative. And that's 12. Does somebody else do it a different way? Who attacked it directly? So you could, if you wanted to, you could write this as 20 minus 11 minus 3 plus 6, just to get rid of those double signs. And just attack it directly. 20 minus 11 is 9. And everything else is still there. 9 minus 3? 6. And 6 plus 6? Thank God. Same answer either way. Yes, ma'am.
I did 9 plus 3, and I still got 12. Did you see where I got that?
Yeah, you did this. You did 20 plus negative 11 is 9. And what's negative 3 plus 6? 3. And it's still 12, right? So you can add or multiply whatever order you want. 6 times 8 is the same as 8 times 6. How's that so far? Is that right? So that's the thing. Math is very often, people don't like it because it's very black and white. There's only one right answer, all this kind of crap. There's actually a lot of creativity. There's a lot of different ways to do things. Yeah. There is Not always, but there is normally one right answer. But there's a lot of different ways to get there.
That's where it's confusing.
I know. That's where it gets bad, that actually there's so many options. So we've gone over this guy a couple times now. What happens with these two minuses? Yeah, they can become a plus. So these two minuses are now plus 3. Different signs, the bigger one's negative. So the answer's got to come out negative. Good. I like it. Cool. 9 is a really easy one. I think those 13s go away, but they don't. Why? Same idea again, right? Minus and negative is plus. 13 plus 13 is 26. And then plus 7.
That's 17.
Just 7, not 17, right?
I thought it was
Is it 17?
Yeah, 17.
Oh, 17, thanks. Shoot. Shoot, shoot. So now I agree. Now it's 43.
I was like, wait.
What is V? What is V? Number 1, number 9.
All right. And what about that last guy? What's the answer definitely going to come out to be, negative or positive? Because everything is negative really, right? Negative 12 plus negative 5 is even more negative now. It's negative 17. And then you subtract 3 more, and that gets even more negative, so now I'm negative 20. All right. So how we feel about those problems there? Is that all right? So be careful. What a lot of mistakes we make is just because we want to get through the problem quickly, and when we do that, we make this kind of, we see this and we think 0. Keep going, it's 0, no matter, because we see this can't, but it doesn't. You got to slow yourself down a little bit. Okay. So now let's look at some new stuff. If there's no old questions. This really isn't new stuff. It's just section 2.5 gives us a little more in-depth order operations. And they start to throw in there, they throw in these order operations, they throw in absolute values. And like I said earlier, that's when things get a little bit freakier. So for example, if I had this here, order operations will always save your ass. Just now we've learned something new. Nothing's changed. What we've learned new is absolute value is in the same place as parentheses in the order operations. So nothing's changed. We just had a new function show up. We got to figure out where the hell does that fall. And that's the same as parentheses. So obviously, what do I do first here? Yeah, in there, exactly. So everything else, the 5 is still there, the minus is still there, absolute value is still there. What's 7 minus 11?
Negative 4.
Negative 4, I love it. Because 11's bigger. It's going to go down into negative territory. And do you see, I mean, this is more than a suggestion. This is a how to survive this class. Get used to rewriting every other freaking thing exactly the way it is. All we're doing is replacing 7 minus 11 with a better number. 7 minus 11 is negative 4. Why write all this crap? Let me just write negative 4. What do I do next?
Absolute value.
I love it. So the 5's still there, the minus is still there, the divided by 2 is still there. And what's the absolute value? Negative 4? 4. The mistake I get all the time is people put a plus there. And why do you think people would do that?
Because in parentheses, it would make it.
Yeah, these two negatives would cancel if they were allowed to, but the absolute value has to be done first. And now there is no negative to cancel that guy, because the absolute value makes it positive. Now what's next?
Division.
Division, good. So 5 minus 2. Yay. Okay. And let me tell you this about the test. I think I will make, I'm still thinking about this, but I will probably make it part 1 and part 2, where you don't get part 2 until you're done with part 1. In part 1, you cannot have any calculators at all. I'm thinking about making the whole test no calculator, but I want to give you the option for more advanced stuff to be able to check yourself. You've got to show me this work anyway. So if you want to plug this in and check yourself, that's fine. You have to figure out how to do absolute value, but we'll see. You can always check yourself there. But the first part will be the one-step problems that you can't really show me work. So I can't let you use your calculator because I need to make sure it's coming from your head, not from some little thing. Okay. So what if I throw in there just everything we've got so far? Yeah. I think we're even grosser than that. Let's see. Oh, I don't know. See, now I've gone off the deep end, right? Damn, Jeff, you should have stopped writing a lot sooner than you did. But I want to show you, I don't care if I start adding more and more stuff. The way to approach math is you break it down into parts. And you only worry about that part. One part at a time. I don't look at this whole thing and I go, oh shit, what the? No. What's the very first thing I should be focused on?
Parentheses.
Exactly. So in this case, those absolute values act like parentheses, so I can do in there first. That's the only thing I'm worried about at first. And 4 minus 9 is a relatively easier problem, right? And the whole rest of the problem stays the same. So what is 4 minus 9? Good, so the absolute values are still there. Times 2 minus 3 over 3 squared minus 2. All that other stuff is still there. We get in trouble, some of us, because we start doing things. I see people doing things like this, 5, 10, and you start to lose. Do you see where it happened? That's 5 times 2 is 10. And then you start to lose where things are, what you've already done. Good God, don't do that to yourself. All right? So what's the next thing I do here?
Absolute value.
Beautiful. Absolute value, negative 5 is 5.
Some people like to get lost in numbers.
Oh yeah.
3 squared.
Yeah, 3 squared is
9.
9. By the way, it's a minus there, by the way, you certainly could do a couple things at once. The more comfortable you are with order operations, you don't have to show me every single damn step, but show me some steps. What can I do next now?
5 times 2.
Yeah, 5 times 2. What's the last thing I do? Even from the beginning, what's the last thing I would do? Division. Division in this case, right? Because it's the bar. It assumes that there's parentheses around there. With me? So what's the top? 7. What's the bottom? 7.
1.
Yeah. So don't immediately give up. I'm not going to put, if I put any of this much of in one problem, it'll be one problem. But don't give up just looking at it going, that's too much shit going on. Take a one piece at a time. Yeah.
So if on the test if we like do the bottom and like the top like together, but like
Yeah.
one at a time,
That's fine.
we don't have to just.
Because I could have done this problem like this. I could have said negative 5 absolute value times 2 minus 3, and the bottom is 9 minus 2. I could have done a couple things at once.
So you won't get us marked down if
No,
we like
no,
do
no.
them before. Okay.
As long as answers don't suddenly come out of nowhere.
Okay.
Or I like the people that do one step and then the answer shows up and they say, I showed you work. No, show me how this got to there. Yeah. But you certainly can do more than one thing at a time. Kelly. Okay. Let's see. There's really too much else freaky in here. Here, you guys try this one here, and then we'll try out section 2.6. Let's see.
Here,
Say again?
that on this page.
No, that's what I just made.
Oh,
Yeah, it's one of my talents.
okay.
Make it up.
You fast with numbers now.
No, I can just ask for it, I can make a problem pretty quick.
Right on, right on.
So I have been known, now this problem, obviously, I want you to simplify, right? Just a warning, I've been known to give this problem on a test, and my only question is, what operation would you do last? So be careful, I like giving conceptual questions. I don't ask you to solve it, I just say, what operation would you do last? And that's the only answer I need. What operation would you do last? Subtraction, I love it. Right? And that would be it. But here, I want you to simplify, so you're good. What do I do first here?
Be negative 8.
Yeah, inside here, then parentheses. So absolute value, -8. Now when I say you could do multiple things at once, if I did 10 here, is that okay?
No.
No. Why? Do I multiply before divide?
No.
And I know in PEMDAS, M is before D, but remember, it could have been D before M. That's just difficult to say.
Depending on what comes first.
Exactly. If it's multiplication division, you do it as it comes. Cool. So now, absolute value -8. 8. 8 divided by 2. 4.
Wouldn't you have to do the
Yeah, you could.
20 more?
That's fine. I mean, this whole thing has to be done, and then this has to be done. But if you want to go strictly by the book, you're right. So I got to be careful, because I'll fall into doing my multiple things. So if you want to go by the book, you definitely have to do square. 16. Now I can do 4. Yeah, 4 times 5, 20. And finally, like you guys said, the last thing we knew from the very beginning, that's going to be the last thing. 20 minus 16. This is why you do not freak out immediately when I give you something that's, this long. You just break it down into chunks, and you only worry about that chunk at that time. There's no, I think some of you guys think you're supposed to be able to do the whole thing, kind of. That's crazy. Okay. So, the last section in this chapter, section 2.6, sort of gets into, say again, sorry. So section 2.6. It takes baby steps into solving equations. Now, if I told you, let me just tell you, and you don't have to think about this, it has numbers in it, but you don't have to think about it algebraically. You don't have to think about it mathematically. If I said, what number do you add 5 to get 7? Now, how did you figure that out?
7 minus 5.
7 minus 5. You just kind of do it naturally, right? What, you guys with me? What number do I subtract 11 from to get 9? What number do I subtract 11 from to get 9?
20.
20. Think about it. 20 minus 11 is 9. So what did you do? What number do I subtract 11 from to get 9? Well, I put 11 and 9 back together, don't I? I undo the thing I just did to the mystery number. So algebra, to tell you honestly, the reason that math problems in algebra, you know, the word problems, which you're not getting to yet, don't worry. The reason they're so difficult is because they're backwards. We don't know the original. For some reason, Fred doesn't know how much money he put into his bank account. Well, what the hell's wrong with Fred? So we got to figure this out for Fred. All right, Fred. How much interest do you make? I got to work backwards. You dork, write this down next time. So and it's frustrating too when you read a word problem. You're like, it doesn't really make sense. And I totally agree with you. Why would Fred not know how much money? He had $20,000. Why would he know that? I would sure as hell know that.
You got
So-
to be careful with the wording too.
Exactly. So that first thing I said, let me see if I remember. What do I add 5 to get 7, I think it was? So what do I add 5 to get 7? Do you see how I can read that equation in English? Yes, sir.
X equals 2.
I love it. So it's just like we saw earlier. I tried to get you to understand that we do algebra all the time. We just don't use x's. We undo operations all the time. We just don't label them in our head like that. The reason we have to get used to this is when the equations get more disgusting. And why do equations get more disgusting? Not just because math teachers like to torture you. I mean, that's true, but that's not the only reason. But also because real life is a lot more disgusting than this. So the equations that govern real life are going to be a lot more involved in this, and they're not ones you can just say to yourself, let me think about that in my head. No, shit, you got to write that thing down and do it. Too much stuff going on. How do I attack this, though, directly? Using algebra. What's my end result? Where do I want to end up?
You don't know what X is.
I want to know what x is. So the goal in solving equations, and obviously this idea is huge. It's like the biggest idea in algebra. If you don't learn how to solve equations, you can't do any math beyond. So the whole idea of solving equations is to get that variable by itself. Because then whatever this is on the other side must be what it is to make this true. How are we doing so far?
Is it almost like percentage? How you?
Not quite yet. Don't throw the percentage in there yet. But you do kind of work backwards sometimes with percentages, but we'll get there. But to do this directly, what would I do to both sides to kill this plus 5? Subtract 5.
So you gotta say something. Negative 5.
Yeah, so the x, this is gone.
Yeah.
7 minus 5, 2. Yes, sir.
What just happened? Because you put the -5 below the -5. Like, why did we do that?
So let me do it again. Now, whatever I do to one side, I've got to do the other side. Or else it wouldn't be even anymore, right? So if I say 6 equals 6, that's amazing, Jeff. Quite a statement. If I subtract 4 from one side but not the other side, now I'm saying 2 equals 6. Now I'm insane. So if I have an equation, how do I keep it equals? Whatever I do to one side, I have to do the other side. I was thinking about Indiana Jones. Took that. You guys have seen Indiana Jones, right?
Yeah.
I know it's 84, but come on. You can see DVDs. Took that gold statue and put that thing. Now, of course, he didn't quite balance his equation correctly, and that's why he's like, oh shit, and runs. You guys with me? So whatever I do to one side, I've got to do the other side to keep it balanced.
Wow.
Guys. So to get the x by itself, I kill the plus 5 by subtracting. Why? Because that's the opposite operation. Whatever I do to one side, I must do to the other side. So here I get x equals 2. So the really nice thing in the early going, our equations will be simple enough that we can check them easily, and we could probably even do them without the algebra. I could just say, what would I add 5 to get 7? I would add it to 2. So you already know ahead of time what the answer is going to be. that's good for getting practice for how to do this step. For when you hit the larger equations, that there ain't no way in hell you're going to think about it. Why don't I divide x by and add 7 and divide that by, screw it. Let me just do the problem.
So is that a certain, what's the name of that when you have to put on the same on one side you do on the other side?
It's called the addition property of equality. And what that title really means is to maintain the equality. If I add something to one side, I must also add that to the other side. So you think about a balance, a scale. If I put 4 pounds over here, I better put 4 pounds over there also, or else it's not going to be balanced anymore, right? So if I start off with, let's do this, no variables. 4 plus 7 is 11. So I have an equation. If I take 2 away from this, I get 9. Is 4 plus 7 equal to 9? No, but if I take 2 away from this, 4 plus 5 is equal to 9. So if I do the same thing to both sides, it's going to end up balanced. Now, before somebody says this, of course, when I have numbers, I could do this minus 2 to either of these, right? So what if I would have done it there? 2 plus 7 is still 9. But when I have variables, obviously I'm going to attack the number with the number, because those I can actually put together. Because I don't know what the hell x minus 5 is. It's not pineapple. I don't know what it is. Yeah. All right, so here, you guys try this one. And this one. Yeah. Don't say it out loud yet. I just gotta keep you back. Hold on.
You want the paper?
What's that?
Like the paper?
Sure. Yeah, just work it out.
Yeah.
So what do I do to this first guy? Because remember, your goal, always remember your goal is to get the variable by itself. So you want to cancel everything else out. That's why we end up doing the opposite operation. So if I do subtract 3 from both sides, I like it. And how do you check yourself?
Plug it in.
Hey, you plug it back in. So to check, you take x plus 3 and you plug the 11 in. Check. Thank God. So you can always check equations. You just plug the solution back in and see if it really does work. So, to make a point right now, because this is going to come up when we get a little more complicated problems. When this is true, then this is true. Are you cool with me saying that? Sounds like more than I need to say, but that's actually how you want to say it. When x is 11, then x plus 3 is 14. Is there any other time that this could possibly be true? No, because that's the only answer I got. Anything else plus 3 won't be 14, obviously, right? Cool. So right now we're going to get possibly one answer. Some of these will have no answer. We'll see something like that later. What do I do here?
You add.
Exactly. The operation right now is subtraction. I want to kill that, so I have the x by itself. So I add 14. So that cancels. I get the x by itself like I want. 7 plus 14, 21. To check, 21 minus 14 is 7. Check.
Did you go the other way with it? Did you add 7 to it?
Two things. I know what you're trying to say. You're trying to kill that 7, right?
Well, no, I'm just trying to figure out whatever whatever number of x is, it has to take away that 14 to get back down to 7.
Exactly.
So if you add 7 to 14, it's gonna be
Oh, I see.
1.
I got it. And that's what we ended up doing, right?
Yeah.
Yeah. So when I do it not as an algebraic problem, if I just say, what do you take 14 away from to get 7? Then it doesn't matter if you do 7 plus 14 or 14 plus 7. And of course, it doesn't matter in general which way you add. But what must I add when I look at this as an equation? I must add 14. You guys kind of get what I'm saying?
Like for algebra.
Because what I was thinking was you were trying to like kill this guy somehow.
No.
But you're thinking like not even algebraic yet. You're just saying, of course 7 plus 14 is the same as 14 plus 7.
Yeah.
That's cool.
I was just trying to figure out what
But you must add 14 to kill this guy.
I want to get rid of it.
You want to get rid of anything that's not x.
So, I mean, is when you do the -3 on both sides, is that like for algebra or like? Because I thought you could just do, in this case, you have like x plus 3 equals 14. You could just do 14 minus 3 and it'll
Well, that's what I did.
Yeah, but you.
But you're right. That's what I'm saying. This is getting us ready for the more complicated equations. Right now, you got to be really careful about just giving me the answer and not showing me work, because the problems are simple enough for you to do that, but they're simple enough so you can feel comfortable getting the practice. So get ready. What do you guys think I do with this problem here? Cool. Because what's the operation right now?
Multiplication.
Multiplication. So you say to yourself, guys, don't say guys to yourself, just. You say to yourself, why is x not by itself? The 3. What's the 3 doing? It's multiplying. So what am I going to do with it? Divide. So if I divide both sides by 3, what happens here? So you get x, like we want. We want x by itself, equals 7. Last problem. You guys are extra antsy. So it's the same exact idea. Why is the x not by itself? Stupid 7. What's that stupid 7 doing? Dividing. So what am I going to do? So you always do that. My students who are in like Math 110, Math 176, they start learning these funky functions and they do all that. I don't care. You take the opposite function and you do it. So the opposite of division is multiply. And sure enough, here these cancel. X equals 77. Cool. Everybody got a practice test, right? All right, so I have the answer key for this on Thursday. And that's plenty for today. We got through 2-6. Oh, yeah. Anybody not get their quiz back? Homework correction, but not so you do the keep up with doing the more priority than correction. Yeah.
So what you're saying is still continue with the homework and then the correction?
Exactly. The new homework trumps the old homework. Unless you want to do it for practice for the test. But the reason I make it do it on the final thing. You do it like way
Everything at once, and then you can use your advantage.
Exactly. I think with like 15. So we didn't get quite to this level here yet. You want your x's all on one side. So these x's are over here and these are over there. So you want to first get those together. So you always want x equals a number. So I want no x's over there. I want them all over there. So how am I gonna kill these x's here, make them disappear? What would I have to do to this side to make those 10 x's go away? Subtract. Whatever do to one side, you gotta do the other side. So those cancel. So you have a negative 17 left over there. Is that cool? Because that's 0 now. That goes away. So you can negative 17. What do you have over here? 11x minus 10x is how many x's? 1x. Well, see, if you ever had x's on both sides, the very first thing you do is move some of them over to the other side and get them all together.
Hey,
Corrections, do you want them to be stapled? You gotta hurry up, that's what the Joel.
Yeah, that's fine. I got it. Was that, that's all stuff that people turn in. So if you're looking for this. Sandy? Yeah. Do it again. Careful. You don't want to do that again.
yeah.
Let's see. There's some homework I haven't graded yet. Some of it's here. Some of it's back in my office. One back in my office. Okay. Don't worry.
No. So I can take care and then have the remainder and I was for the 0.9.
Oh, but it would be 0.9. What is 0.9? How is that? How do I write that as a fraction? 9 out of 10, because that's the 10th place. Careful, no. But it's not out of 10, is it? It's out of 13. So the only real way you could do this is, blah, 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 you get this 9 down here, is to write, you could write it in 9/13.
So whatever number is here, I just put it over.
Because that's what I'm dividing by. And see, that's why this decimal is ugly, is because 9 divided by 13 isn't good for decimals. Anything over 10 or 100, that's exactly what decimals are. That's why those are nice. That would be a gross decimal.
And thank you. How do you find the average?
Oh, so how do you average your grades? If you made like a 70 and an 80 and an 82, if you had 3 grades, you would add them all up and divide by 3 in that case. How many grades?
Divide by how many there are.
Exactly. Cool. You're welcome.
2.
All right.
So the problem with this is, so going to 25, would be 25 over 100.
I like it.
Okay, right, and, that problem is.
Yes.
What can you say fraction, or time fraction?
Don't look at it like a fraction then. Look at it, this is x divided by 7, right? Don't even think of it as a fraction, because all fractions really are is division products.
Okay.
So you look at this as an operation, just like you would here. You say, okay, that operation is subtraction, so I'm going to, how do I kill it?
Oh, sorry.
That's all right. So I'm going to add. That operation is division, so I'm going to do the opposite, multiply.
Okay.
So don't think that's a fraction. I mean, in one case you're right, but all a fraction is a division product. So you think of the operation when you're solving, that's a division operation, so I'm going to kill it by multiplying. So it's not even, you don't have to look at it as if it's a fraction, because that freaks people out. Because fractions are freaky, because they're divisions I don't want to do. So they're always going to be a little weird. But here, this is a division I don't have to do, because the first thing I do is kill that stupid 7, right? It's even better. So don't think of it as a fraction, just think of it as, I'm going to multiply to kill that division. Cool. Oh, good. Thank you.
Okay,
So we start this here.
correction grade?
Yeah.